Propulsion touches more parts of your life than you're even aware of. Whether it's flying in the skies, putting satellites up into space with the cell phones that are in your pocket, to all aspects of life, propulsion is integral. If you look at where the nation and we as humans are going in the next 20 or 30 years, it's very clear that propulsion is going to need to be an incredibly important part of that. Ursa kind of entered the scene with that premise when we're trying to be at the leading edge of it.
I'm Joe Lorienti, and I'm the founder and CEO of Ursa Major.
My name is Nick Doucette, and I'm Ursa Major's Chief Operations Officer.
I'm Lauren Powers. I am the Portfolio Director for our launch propulsion systems.
My name is Brad Appel, Chief Technology Officer here at Ursa Major.
I'm William Summers. I'm the Chief Engineer over the Solid Rocket Motor program here at Ursa Major.
My name is Bill Murray, and I'm the Chief Product Officer here at Ursa Major, and I run the Solid Rocket Motor Division.
3, 2, 1, ignition. Feature number. Take out for 1,500 feet and 8 stop hook grid.
The best starting point in my mind is really the space race with the USA and Russia. We achieved amazing things back then, technological feats that I think we, in some ways, still have yet to replicate today.
If you would look back to the 60s, most inventions that took place were happening because of NASA and affiliates.
The United States built up such a head start in all of these areas, and it's still riding those coattails today, but the trends are not promising.
If you look at the technology that we were building and flying in the 1960s, 70s, 80s, and what we're flying now, they're not very different.
There's very little competition, hence very little drive for innovation, because innovation means risk, right? Innovation means cost.
Really, until SpaceX came along and started reusing rockets, we didn't see massive innovation in aerospace from the end of the Cold War. We are no longer innovating. We're no longer sparking creative new companies.
What that has done, it's been going on for a couple decades now, is we're behind. We're a fraction of the size of China. So they've already got an advantage as far as resources are concerned.
If you take SpaceX out of the picture, I think China is launching at 4 times the cadence of the US.
What we don't want to end up happening is a slow chess game of China and Russia developing better missile technology, and one day we wake up and we're 10 or 20 years behind.
I feel that there's a strong possibility that we will be sadly left in the dust if we don't make some pretty immediate changes.
What we're trying to do is offer the Department of Defense and other aerospace partners types of propulsion technology to counter these very fast hypersonic threats that China and Russia are putting forward.
There's hypersonic technology, with a variety of applications, both defensive and offensive, and then solid rocket motors for the aspect of missile defense and deterrence.
Everyone's here because Hadley, our 5,000-pound thrust engine, is going to fly for the first time, and we're watching it drop from one of our first customers, Stratolaunch.
First flight's a big deal for any aerospace company. There are a lot of companies out there that are young that have ideas and PowerPoints and drawings and hardware, but actually having it verified in operation is a big deal.
So once they get up to the proper altitude over the ocean, they'll drop the test vehicle. Basically, Hadley will light and take it up to high speed.
As a company, since day one, flight's always been an objective of ours. Obviously, for us, we don't fly vehicles, so we count on customers to do that for us.
Hopefully everything goes well. We get a drop, we see a light.
There's a skill base and an industrial base and a sort of competency base that we have to build up again. And there's challenges in that, and there's failing, and there's, God, this is hard. That's manufacturing. You know, hands have to make it.
When you're in the development life cycle, when you are fielding a new technology, failure is one of the best things that can happen. You want to push hardware to its limits. You want to quickly learn and iterate and change the way that you're thinking about hardware.
Our key is iterating fast, learning what we can on the test stand in a relevant environment so that we can field new platforms more quickly than ever.
We pride ourselves on the speed at which we can deploy products, complicated products, systems that are moving at 65,000 RPM and producing, thousands of pounds of thrust. And we do it in, I'd say, industry-leading times.
One of the things that makes Ursa so unique is the fact that we design and manufacture our engines in the same place. We're also testing and developing those.
You could have a part fail, engineer go back to the computer, redesign, reprint, machine, qualify, and get it back on a platform and get it back testing within weeks.
And it's such a critical technology that you need to focus on it. And in order to focus on it, you need experts to focus on it. Ursa's those experts.
Ursa Major, at this point in time, has assembled a world-class team and the technology and experience surrounding all of that to move quicker than any propulsion firm out there.
Colorado offered us the opportunity to test rocket engines every day and do so a 30-minute drive from an incredible place to live.
I worked multiple programs for different nuclear ICBMs most of my career. I wanted to be able to be a part of a company that was going to improve the entire landscape. We're actually already seeing it.
We need to see companies pushing one another and focusing on technology versus seeking to own a single mission and really excel at it.
So that's one thing that I think is really valuable, that non-tangible asset that we're providing, which is that spirit of competitiveness, which increases competency everywhere.
We need to, as an industry, couple the rapid development and iteration and blowing things up with the ability to take the technologies that mature out of that and quickly get them in the hands of operators as safe end uses.
Really, our engines are here to enable the industry to grow the technology and also potentially be deployed to actual applications for hypersonic vehicles. So it's the biggest milestone in the company's history.
5, 4, 3. Release.
Good release. Stable. Ignition.
America has always been this beacon of building and making. And I think if you combine the hustle and grittiness of that American frontier with tremendously accurate engineering judgment, I think you found yourself what the early space program probably found itself doing back in the 50s and 60s, making great decisions, moving really quickly, and doing it without the glam and glitz of all the Silicon Valley that kind of comes with that type of backing.
What we're doing here at Ursa is going to have a huge impact on the capability of America to be able to maintain our status as a well-defended and well-protected country. And I believe that we have the capability to provide the impetus for a big shift in the industry.
Ursa Major is beginning to have a global impact, and that should only accelerate over the next couple of years.